Hi, and welcome to Cool Jobs. I'm Caden Amoroso, your host of the show that aims to answer the question that every kid is asked at Thanksgiving by their relatives, which is, what do you want to be when you grow up? Not knowing the answer myself, I've decided to set out on an interviewing adventure where I would find individuals who have achieved the dream of working fun and rewarding careers and ask them how they found these jobs. What are some of the challenges these jobs present? And what keeps them motivated and driven to continue their work. All of this so that other kids and teens out there can learn with me and find the answer to the same question that I struggle with, which is, what do we want to be when we grow up? The following is an interview with Richard Doberstein, who is an experienced test engineer in the biomedical field. Richard's knowledge and experience in test engineering presented unique insights on the impact that engineering has on the world and led to a really fun conversation. Without further ado, please enjoy the video.
During your life, was there a point that you realized that you were interested in becoming an engineering or pursuing that degree?
So engineering was something that I knew I was interested in very early on. It's a um, it's a combination of inquisitiveness and understanding. You want to know how something works, and then you want to understand how the world works around you. So it was that endless quest for knowledge that led me down the road of engineering.
Was there any activities you did as a kid that you realized you were like, hey, this is kind of like an engineering activity, or this activities that like that pursuit of knowledge pushed you towards?
Every engineer played with Legos, and if they deny it, I would definitely question it because Legos is, you know, we draw and you color and you try and color inside the lines, but with Legos, it was for a lot of kids the way that the things they were picturing in their mind, they were able to make in their hands in front of them and actually look at and create what their mind's eye was seeing. And it's a form of expression. And then from there, I went to this summer camp called Camp Invention, and it was at the elementary school, grade school kids, right? And my parents gave me their old audio amplifier for the surround sound, and I took it in that day. It was so heavy I could barely carry it. Took it entirely apart and to try to like, I didn't know the names for what I was looking at the time, but the idea of taking something apart, figuring out how it works, and then trying to put it back together, and then failing to put it back together because you lost some of the parts, that's all part of the process. And I think that definitely helped to foster it. And then Bill Nye is another one that if anyone denies him like the Legos, I would doubt it. Uh, to take the quest for knowledge and understanding of the world and turn it into a comedy show is hysterical. So it was cool to see somebody who is very much so a nerd, but a cool, charismatic nerd telling fun jokes along the way. I think that definitely added a lot to the allure of this field.
Oh my gosh, I love Bill Nye. And did you ever watch Mythbusters? I feel like
Yep.
that's
So
in the same
Mythbusters is
vein.
a lot. Mythbusters is basically what I do every day.
That's what I was
Uh,
thinking.
Yeah, the myth is that your device complies to the regulations and the standards, and I'm here to prove whether it does or not. And that's what I do on a day-to-day basis. So, as a test engineer, I test uh, manufacturers' products against the global regulations that have been written for that type of product. I test a lot of medical equipment, and so it's not only does the medical device perform its intended therapy, but also does it blow up in the operator's hands while they're trying to use it. So it's two-pronged, the essential performance and then the basic safety of the product. And it is Mythbusters. The myth is they designed it correctly, and we'll find out real quick.
I mean, that sounds so exciting just to like push things to its limit. What kind of engineering field did you go into? Because I know there's like a wide range of different subsets of engineering. What did you specialize in?
So my education was biomedical engineering, and that's why I got a degree in. It was from Carolina, Chapel Hill, and it was the one of the two engineering courses they offered. It was that, or it was computer science. Which, seeing what's happened over the last 20 years, computer science definitely has had its heyday. But the med tech industry, pharmaceuticals and devices, pharmaceuticals, was very big for a while, but now we're seeing a renaissance in instrumentation and medical technologies. Uh, the ability to use lasers to measure a short distance into your skin and to look for tumor cells under your epidermis. That's a very new technology that's breaking ground. A lot of other cancer treatments that use this device to perhaps deliver a therapy for the removal of cancer, and using electrical signals to create these, whether it's a cutting or an ablation type therapy or a muscle stimulation to help rehab. There's a lot that the miniaturization of electronics has created new medical devices, and that's what we're hoping to test, that those emerging technologies and help those manufacturers get to market.
Wow, I had no idea there was so much to the biomedical engineering field. That's fascinating. It covers, it sounds like it covers everything in like like medical machining wise.
It was cool because I got to take all the biology a doctor did, all the electronics that a an electrical engineer would take, and all the mechanical engineering courses that a mechanical or civil engineer might take. So when I came out of school, I had a very uh, theoretical knowledge of all these spaces, and then I got this job testing right out of school, and so very quickly it became pure double E. But whenever there was a new device, because of my biology background, I knew the intended therapy. I knew what they were trying to have the device do. So I was able to ask, in my opinion, better questions of the manufacturers to see how they had validated the therapy. Obviously, a clinical trial will teach you everything you need to know, but through the research of clinical data that's already out there, you can create a device with an intended therapy, an intended measurement, a function that it's supposed to serve, and that's immeasurable. Whether it's a design input or a design requirement or a user need. Uh, so being able to ask the right questions and understanding the device in front of me really kickstarted my career, and that's why I was able to start with medical equipment immediately instead of doing, computers and monitors for the first few years.
Yeah. I mean, that sounds so, it sounds like such a fulfilling experience to be able to like draw from all those sources of knowledge that you've accumulated throughout your education and then use them in like one direct field. In this like Mythbusters-esque, I was looking on the website, they had heat rooms, they had a picture of what looked like a plane in a wind tunnel. They had giant giant tanks of water that they submerged stuff in. What what's your favorite kind of testing? With so many different test chambers, what's your favorite one to use?
So that's a great question because all of these different test rooms, test chambers, test tanks, all these things are intended to simulate what the device will experience in the real world. If a device is intended to be used outdoors in like an emergency medical services setting, you're going to be testing it at a higher ambient than a normal hospital setting. So it'll be the device will be hotter. So if it runs hot, there's additive effects of heat there. The I think my favorite test equipment. Oh man, this is a good one. I like I like ball pressure, and it's the dumbest, stupidest test, but I like ball pressure because you put the sample in an oven and you make it warm. So that's, measuring a thermal response of this plastic. You have a device sitting over it that creates an impression into it, and so it's a mechanical deformation, a change in that. And putting the two together, you get to see how long it will survive as an electrical boundary for its expected service life. So it's electrical safety, strained by heat, and the mechanical properties being measured. That's the big three of our industry. So to break testing down into its simplest form, it's temperature, how hot it gets, and how it responds to heat and cold around it. There's mechanical, which is everything from moving parts to sharp edges to trapping zones if it's a device that's very large. And then the electrical will it shock you. And then from those three, the fourth one would be performance. Does the device have a specific output it has to do? So we have different ways to challenge everything, but ball pressure is hysterical because all three come together. And while it's electrical safety requirement, you get all three of them being considered, and that's really what I think about all these hazard-based standards approach, this hazard-based testing, is you have to understand the big picture of how the device is going to be used, create worst case conditions for how you're going to test it, and then go forth and do the testing. And it's all negotiable. If it's something that is you as the tester think is foreseeable, but the doctor who helped design the product knows it would never happen in a hospital setting, then you get to scale. But sometimes you come up with something that, you think of what the dumbest nurse might do. The nurses, God bless them. We can't do anything without nurses, but somebody who's maybe calibrating the equipment, somebody who's maybe just installing the equipment doesn't know what to do. If they were to drop it, you might not visibly be able to see what's happened when really something inside has gone terribly wrong. And so our testing is to ensure that those accidents don't result in a risk to the patient. And that's really what we're here to do, is to create patient safety.
Mm. And when testing these products, do you wear any kind of safety gear or like a hazmat suit or like a fire retardant suit?
So I've had to wear a full bunny suit head to toe a couple of times.
Just for a layman like me, I'm assuming bunny suit is like scrubs or
Yeah.
that's just like a
Picture scrubs. So it's like
Mhm.
coveralls that you would pull over your street clothes. You would put a shoe cover on. You may have seen them if you've ever done an open house or had construction and contractors at your home.
Yeah.
Those cover the shoes to keep any dust and debris inside there. From there, the bunny suit, whether it's coveralls and they zip up or top and bottom, the idea is that anything you may have walked in with off the streets are covered, and then the hairnet and just more dust and dandruff if you have it. Sometimes, whether it's a hospital clean room environment or the wafer processing, so everyone talking about NVIDIA and Intel and all the chip manufacturers, they operate in a clean room, and that's to protect the equipment that they're building, more so than ourselves. But it's always hysterical to put all the hairnet, and then I have a little bit of mustache, so I put one on my face usually. So that's ultimately because so here's when that's really critical. I already gave you the idea of the wafer manufacturing and that kind of sterile room, but a sterile medical device, it is going to be opened out of its sterile pouch immediately before surgery, and it cannot have any contaminants in there whatsoever. So the people that have certified clean rooms and those processes and those manufacturing processes, they really do everything in their power to eliminate all debris that could possibly come in. The cleanest rooms you'll ever be in. There's no dust anywhere. The HVAC has so many filters in it. You have everybody's wearing the full suit, and so though, but that's why it's so important, is because the doctor's not going to say, I wonder if this is sterilized. They have to be able to trust it right when they're about to use it on the patient, and that's probably the most rigorous site to do work in.
What's the funniest way something's gone awry when testing? Or has there been like
Oh
one like
goodness.
zany example where a product just completely exploded?
So I have started more than a couple lab fires. Um, I've seen a shower of sparks. I've definitely seen a transformer start to melt its insulation and just go up in smoke. Um, it was actually not me, but one of the testers on my team. We were doing, the heated floors.
Mm,
You put this. So the way that heated floors work is you have this coil of wire. So this wire is going back and forth on this net, and you lay this net down, and you pour concrete over it or a little bit of grout, and then the tiles on top of it. So you have this wire going back and forth throughout the floor, right? And it's transmitting an electrical signal with some intentional loss in it, some resistance in the wiring that dissipates heat. All loss in electronics typically dissipate in the form of heat or sound. You can hear a failure before it happens. Like, I can smell which component failed now that I've done it, however many times I've done it. I know the difference between a transistor and a capacitor by smell when it pops. But in this instance, it's some sort of copper, but a blend that has a high resistance. And so as it and my engineer was testing it, a colleague of mine. Um, so he had done the testing. He knows what happens to the control box. He knows what happens on the wires. It's within what the manufacturer said it would. And he said, that's great. And he broke down the test setup, pulled all of his measurement equipment off, and he rolled up the net with all this wire that's still warm, not hot,
Oh
warm to the
no.
touch, not hot. So if you coil up 100 yards of it, you can see where this is going. All of a sudden, the center of this bundle of warm wires became much hotter than the wires on the outside, and it ignited. And so later that day, I got called out to the lab. It's filled with smoke. I'm like, what happened? He said the test ran perfectly, and then I rolled it up. So that was pretty cool. And also just, you think it's safe until you do something boneheaded with it, and then it's no longer safe. And we call that the human factors. Human factors engineering, usability engineering file is okay. You built a great product. It has a great function. But can the person who actually uses it, installs it, works with it, are they able to detect all the risks? You can imagine the difference between a home healthcare device where a child might get their hands on it versus a surgical tool where only a surgeon will ever touch it, and then the whole gambit in between. Sometimes you have some silly users, and home electronics have a whole lot more rigor than professional tooling and such. Another one I did was, and I won't name the company because, but it was one of those pellet grills, right? And so the pellets that feeds it, the pellets feed it, and it gets hot. It's a smoker, right? So the more pellets, the more heat, but it can turn itself on and off to deliver the correct amount of pellets. Well, what's the risk there? What happens if it delivers too many pellets? So it's got an electrical control box and then the big smoker. And I said, okay, engineer that I was working with on this project, he said, I don't know how to single fault the controller. I don't know how to test the controller and trick it into failing. And I said, well, what happens when the controller fails? It fills the thing with hops, or it fills the hopper, like all the pellets will be in the heat source. So we just dumped an entire bag of pellets into the smoker and lit it on fire. Now we have tremendous ventilation in the ceiling, pulling all the smoke off. But yeah, I lit a smoker on fire to show that the electrical control panel did not exceed its thermal ratings. And that's how we finished the testing. We said, congratulations. Your controller can do anything at once, and we can't find a way to make it fail because we literally set it on fire and it's still okay.
Wow. That's crazy.
It was fun. It was a fun day at the office. We weren't able to make cheeseburgers. It was way too hot, but and that's, it's a little bit nefarious thinking,
hmm
like and for cybersecurity, we didn't even touch on this because it's not products, it's software.
Oh yeah.
But the cybersecurity, everyone's getting hacked and everyone has to put these security measures in place. And every cybersecurity team that I've ever had the pleasure to know, and I've talked to a few of them, has that one guy with the, a little bit nefarious undertones to him. He doesn't look like much. He's in his cotton hoodie, but the guy is diabolical. And he knows where the threats are, and he knows how to. He's probably a former hacker or some kid who's pirated a lot of movies, but he knows where the threats and where the vulnerabilities are. And having one of those on your cybersecurity team allows for you to build a safer product, one that's more locked out by having that nefarious guy. So sometimes in testing, you really have to play the devil's advocate and say, I think this could probably fail in this way. I'm going to do this to it. And they're like, nobody in their right mind would ever do something to it. And I say, well, you haven't built a way for me not to be able to do it. So I'm going to do it and see what happens. If you're an engineer and you want to build something, quit thinking about everything that can go right. Start thinking about things that can go wrong and really put yourself on the other end of that and channel that nefarious side of your mind and really try and torpedo your own idea. And that's going to create rigor and create a better product the more times you iterate on that.
Mm. Wow. Yeah, I guess that's what you're talking about at the beginning too, about just like having blind spots because it's your own design.
Yes.
Just not
Yeah.
seeing
People
it
think their
because you've been
babies
so
are
focused on
beautiful.
building it right, you haven't thought about if you built it wrong.
Yeah, exactly right. And that's the third party testing. That's what we do is
Mm.
just make sure you covered all your bases. Yeah, it's fun. I like it. I don't think I could see myself doing anything else.
This is such a interesting field. What advice would you have for a young person who wanted to pursue test engineering?
So testing,
biomedical engineering, if that's better.
yeah, most engineering students want to be a designer, right? Most engineering students want to come up with the next iPhone or the next big medical device that's going to change the world. And God bless the people who want to change the world. R&D engineers are brilliant. They are designers, they are artists, they are the creatives of our field. And so I got into testing, which is not R&D. I think it's more fun than quality, which is probably another avenue that most engineering students don't want to get into quality. It's a lot of audits and paperwork and tracking. But all these pieces together have created a system that you can rely on. The whole purpose behind testing is that Thomas Edison, when he invented electricity, invented the electrical test lab, ETL. So Edison himself, who introduced us to electricity on a big scale, he came up with the idea of, okay, now that I've created this novel thing, electrons being used to do work, we need to allow people to use it safely. And what he did was by electrical test labs, what he did was he would take other people's inventions, whether it's the first toaster or the first light bulb or the first light holder, and he came up with a method by which to test them. And that made it safe to install. And those principles still exist today. OSHA is a organization in the U.S. that ensures safety of people. Typically, OSHA you hear about for workplace accidents and whatnot. Well, they want to see certified products being used so that they can trust that those products are safe. So you can't bring a bunch of equipment together in a room and just start testing and have people losing fingers and shocking themselves, all these adverse events that electronics can cause. So it's all built on what Edison had started, is the idea that we're going to standardize, we're going to create a list of rule books, of law books for engineering, that if you comply with these minimum requirements, you're safe enough to be used. Anybody who works with a blender can find a way to remove their finger with the blender. But the idea is that you make it as simple and safe as possible, and you remove accessibility from those harmful parts. And by creating a list of standards, they created repeatable test methods that every manufacturer has to follow. And by doing that, us, the consumer, get to buy these electronics and know that we can trust them and know that they're safe. So that's kind of the origins of where testing came from. And the only reason that third party testing exists is because of the human element. Everyone believes that they built the best product. Everyone believes that their product is safe. Everyone believes that it's going to change the world. And sometimes it takes a third party to come in and say, you maybe didn't consider this. What is the risk of that? And really try to scrutinize their design, because everyone has blind spots or vanity. They think it's perfect and they just don't want to change it. So having third party agencies like Keystone, who I'm with now, to come in and perform that testing, that's incredibly important, and it's the only way that we can trust the world around us. Uh, and with the new AI coming out, they're creating new standards for AI learning. There's guidance documents on how to coach and train AI for medical applications. So this big AI bubble right now, people are saying AI is going to make all the decisions for us. Well, yes and no. AI is allowed to do a lot of the front end work, but a doctor still should be reviewing it. And it's very hard to get approval for an AI tool only, because them and the doctors, the AI and the doctors, need to continue to agree in order for that AI to remain on the market. So there's always a new emerging technology, and whenever it's new, they don't know what to do with it. They don't know how to regulate it. They don't have a standard written for it yet. And that's where hazard-based analysis, finding and detecting the hazards, understanding the therapy or diagnosis that's being done. These are these device requirements have hazards inherent to them, and you have to analyze those. It's called the risk management. So that's governed by ISO 14971, not to get into the weeds, but it's a methodology of thinking, of detecting these threats and reducing them down as far as possible. And that's where all the new tech follows that same thought process, even if there's not a standard written for it. So that's when a person says they're interested in engineering, and they get excited about learning how the world works. You can design one product over 10 years, or you can certify hundreds of products over 10 years. And I chose the latter. So I've seen a lot, and I'm not an expert, I'm not a designer, but I do know how things fail, and I know when more safety is needed to put into place. Um, I think that answers the
Oh
question
my
of
gosh. No, that was an amazing I was enthralled. It's so interesting. I realized how much I take for granted all the safety measures on only the electronics that I use and everything else. I bet there's stuff this chair that could be like that were put in place to it's amazing how wide this
just,
field is, this just
oh yeah.
testing engineering.
And it goes beyond electronics. I mean, if you want to mention the chair, how much weight can steel support? How much can it support when the legs are welded together instead of screwed together with bolts? The material, does it make you itchy? We call that biocompatibility. So there, even outside of electronics, the textiles industry has a whole lot of oversight about the nature of fabrics and to make sure that people aren't allergic to their clothes. I mean, when's the last time you had to worry about buying the wrong shirt because it'll give you a rash? Hopefully not at all, not ever.
Wow, that's so much to think about. Um, and so with all this testing, and like you mentioned, testing 100 things in 10 years versus engineering one, what does success look like to you? Does it look like just in any avenue? It could be personal or career wise.
I'm a big fan of the show, and I've thought about this question a lot because success in a government oversight mandatory like quality step for manufacturers isn't exactly a lot of people's passion project. So I'm going to take it a step above and talk about what it means to be an engineer. Engineers live for the aha moment, the light bulb clicking, where understanding sets in, and you find yourself that you know how the problem you're trying to solve, how the thing you're trying to understand, that light bulb moment, that aha moment is incredible. And it's the feeling that most engineers spend their whole life running towards. So my aha moments are when I can find a manufacturer who has a great idea with a terrible design. Just they tried to do good engineering practices, but they're a designer. They were a dreamer. They don't know how to actually build something 1,000 a month to distribute worldwide. They just don't have that understanding. So when they reach out to us with an idea, and I get to work with them from a preliminary design review to help them identify all their risks, where I help them to do the testing and demonstrate through tests that all those hazards have been reduced as far as possible, and then they start selling. And that's the best feeling is when my manufacturer has their aha moment and say, I can make this device better. I can fix it. I can get it through the standard. I can get it to all these markets that need it. And some of the ones are just so rewarding. A ventilator that's built incredibly cheap to service India during COVID. Yes, help me save one of the most densely populated places on the planet by building a device that is $50,000 in the US that could be manufactured for hundreds of dollars and help people. That's what gets me out of bed each day. So helping the dreamers navigate all the regulatory hurdles, helping them uh, build safety into their product, and then ultimately go out and change the world themselves. It's a source of pride that I carry every day.
That's incredible. Yeah, that's really admirable. And to look at it that way is so interesting. And it makes so much sense.
Yeah, it's something that luckily most people don't have to think about. Most people they
Hmm.
just say, "Why can't we have good products in America?" Well, we do. In fact, we're one of the top countries for designing, but our parts come from everywhere. It comes from I've got parts from China being manufactured in Estonia, being sold to Germans and the global markets. And because of Zoom and because of the digital tools that we have, the whole world is working together towards a common goal. China manufactures all of the components and all of our electronics, but the designers can be somebody. in their parents' basement with an idea, and the infrastructure is already there for them to source components, for them to find a way to build their product. And then people like me say, okay, you've got a prototype. Let's see how close you are to actually building something you're allowed to sell. And so it's really cool how many companies I get to work with that truly have no office. They're just engineers spread throughout the country or throughout the world who work together in a common goal to try and make the world better. And it's very cool. And the engineering and the manufacturing world, it's super cool. And there's so much new tech that's coming around the corner that I would encourage all students who have an interest in STEM to pursue engineering to try and keep some of that awesome designing and manufacturing here in the US or wherever they're sitting. Honestly, the more builders we have, the better tomorrow we can build.
Was this like world-changing career what you had imagined you'd be doing when you
No,
were 5 years old or 10 years old or a teenager?
I had a writing prompt in middle school where I said I wanted to be an astronaut. Now, if I had stuck to that path, I'd probably be in the best shape of my life and working for like SpaceX or for Bezos's rocket company. Uh, I mean, I think that a lot of that was true. It was true to my inquisitive nature and that part of my side that I knew existed. But I found this job because of a global recession. It was 2012 that I graduated. 2008 and 9 was really rough for the country, and I took the first job I was offered. I didn't have a high GPA. I didn't have a lot of um, places hiring. I took the first job that I got out of college. But what I found when I got there is, heck, 2 years of this, I'm going to be an expert on how to build products. And then 2 years go by and I realized I know a lot, but there's a lot more that I don't know. And I just kept growing and growing and snowballing this. And I made it a personal goal of mine to just test everything, try to get my hands on everything. And, there's like probably 150 different medical particular standards for different types of equipment. And I think I've at least tested a third of them. So I have a long way to go. But I've done linear accelerators, I've done X-rays, I've done lasers, phototherapy, I've done ultrasound, I've done infusers and injectors, I've done hospital beds, nursing carts, I've done dental equipment, I've done everything that you can think of in a hospital, I've tested before. And it's just an endless quest for knowledge. And every time I successfully complete a project and I certify a product, that product goes out and enriches however many lives. And even though I didn't design it and I wasn't the person who financed the company, I still feel like I did my part to the common goal.
Right, you still had a hand in it. You still advanced the original dream of that product helping people. That's really
It
inspiring.
feels good. It feels good, but and testing it's not for everyone because, and this is a fun one. It's you got to be an engineer enough. You have to recognize what you're taking apart and what you're looking at. You need to be an engineer enough to know the components being used and how it's supposed to work. You need to be a lawyer enough to be able to read the standard and make sense of it. Some of these standards are 1,000 pages long. I've had, and when multiple standards apply, it can get pretty unwieldy. So being able to read those legal documents, those regulatory documents about how electronics have to be constructed, that's the second tenet of testing. And then the third one's customer service. Um, there's every industry you have everybody has a boss, everybody has a customer, and those customers opinions matter and you have to take care of them because you can't teach somebody how to redesign their product until you win their trust. And so to be able to do all three of those keeps all the sides of my brain sharp, which is a blessing. I enjoy it immensely. And so if if somebody were to come to me and say I'm an engineering student, but I don't have any ideas for what to build, but I get it. I get I get what hardware is. I get what these rule books look like. I'd say, great, go into testing. Test a bunch of people's cool designs. Learn 100 ways not to make a medical device. And then, hey, you might have an idea, and then you can go out and make it. But it's great proofreading other people's work. Some of the personalities you get to meet, some of the smartest people I ever met were customers of mine, and being able to talk to them and geek out about their cool technologies. is a huge part of the job. And for those engineers who like to talk to people, highly recommend getting into an industry where you can get in front of as many smart people as you can, and testing is just one of those.
Mm. I mean, because you're working with so many engineers. You got
Oh
to work with the
yeah.
people, yeah, and you're also working with other testers, and just, yeah, it just sounds like a really good melting pot, especially for people who like want to make something eventually too.
Yeah, a lot of people have the itch to make something themselves. For me, I do that with my hobbies, you know.
Mm.
So when I want to feel creative, I'll, very simply reorganize the room, or, install that dimmer switch that I've been like, that's a fun thing, it's just playing with your hands. For a long time, I made beer, which is a lot like cooking, but the hardware around it, I had to build a brew setup, so it got to be pretty big. But most engineers have a knack for wanting to make something. And whatever that is, that's the creative side of an engineer. So and those without any ideas, it's fine. It's fine. Get into quality, get into testing, help other people with their ideas, bring the rigor of documentation that they might not have, bring the worldliness of the site to identify different hazards. Because that's there's a lot of ways to help this industry of new tech, emerging technologies, and especially on the medical front, there's a lot of ways to help that business without being the guy who's like founded the company, the Mark Zuckerbergs of the world. You don't have to be top dog to make an impact, to make a difference. And ultimately, helping people get to market and getting their products on the shelf, it's a great victory within itself. Yeah,
Yeah.
I
Well,
could I could ramble on this all day.
oh my gosh, I could listen. I could listen. I've been so interested this entire time. It's just
Yeah.
fascinating. I Yeah, no, I played with Legos when I was a kid, so I watched Mythbusters 2 when it was on Netflix a long time ago. I watched the whole series a ton of times. I got back into it recently, and just yeah, just all these um all these questions being just like asked by both the tester and the original engineer who like designed it is so interesting to see how it all comes together and all these like what you were saying before, all these little, not little, all these impacts that come after the original design, how they really push it forward and make it a reality.
Yeah.
It's
I
just
mean,
been so interesting.
Socrates said that question everything around you, and the designer did, and they questioned the world around them, and they made up a new product, and then it just keeps going, it keeps
Hmm.
rolling. Through discourse we find truth. That's what lawyers believe. Through testing we find out how good your device is.
That's the truth. Well, thank you so much for all this wealth of information. I feel like I've
Absolutely.
learned I know I've learned so much about engineering and about biomedical engineering, about the biomedical field, about the testing industry. It's all so fascinating. And I just want to thank you so much for spending the time to be interviewed by me. I really do appreciate it.
My absolute
Um,
pleasure.